Welcome back. Submit of code day 11. Monkey in the middle. It's about monkeys that worry and what their worry levels are. $10,605 for the part 1 sample. Looks like quite a long problem statement again. Monkeys are playing keep away. Predict where the monkeys will throw based on how worried I am. Okay, not my level. Okay, the puzzle input looks quite complicated. Ah. Okay, so each monkey has a number of items, and at each step, I'm guessing, we run this operation on its items, and then test it using the test, and pass the item to a different monkey based on the result of the test. Are the tests all divisible by? The inspection didn't damage the item. It causes your worry level to be divided by 3. The monkeys take turns inspecting and throwing. And in the order listed. So we do the operation and then we divide by 3. Okay. I'm going to have to focus on the 2 most active monkeys. Count the total number of times each monkey inspects items over 20 rounds. Multiply together the 2 most active. Well, I don't have any structs, so this might be a bit ugly today. How many monkeys there are? Oh, not too many. Okay. That's good. In that case, I think we will not pass. Okay, I'm going to give it some silent contemplation. So we're not going to be able to run the sample input, but that doesn't necessarily matter. So we want to know the levels that each monkey has got. Right, we're going to do it. Monkey levels, monkey off. Monkey divisor. Monkey true. And monkey false. And we'll have monkey 0. Okay, so that's how we're going to initialize our monkeys. This seems error prone and risky, but in the absence of copy and paste, I don't have a lot of options. So if I write everything and it looks correct, but it's still getting the wrong answer, I'll have to revisit all of this and check that I've wrote all the numbers correctly. I'm actually wondering if just implementing it as given is going to be too slow. Probably not for part 1, but might be for part 2. Maybe we're supposed to come up with some trick to work out how to apply several transfers in one go. If you're playing along at home, maybe you could check the numbers for me, and then you can have a frustrating watch as I go around in circles fixing the wrong thing. Okay, good, that's all the info. Now, what we want to do is we want a function to run around, function to run a monkey, and then I think it was 20 rounds, and then we want to know is it how many times a monkey has transferred or has been transferred to. How often a monkey inspects an item. Was it by their monkey ID? No. Multiply the two numbers together. Okay, so what does one monkey do? What we're going to do, I think, is have remaining things be a new grar. So we'll go over each value, and what do we do? Old, we get n of zone I. New is by 3. And then if u mod m divised m equals 0, then we want to pass it to m true, else we pass it to m false. So in fact, we don't need remaining. All we know is that once a monkey has run its go, it's got rid of all its items. So we want to go trunk and level down at 0. May need to check if that's how go trunk works. Maybe it's more reliable to do this. Okay. Oh. Count the number of inspections. If A is larger than B, we want A to come first. Yeah. Let's try that then. I'll have to do the multiplication myself. Oh, that's not good, is it? That's the first crash we've had this year. So what happened there? Maybe we tried to call an op and it was null. 61 the last? No. 76 is a number for monkey number 2. So for some reason, I've got these two on my right. Oh, that's going to run infinitely many rounds. No. Not the right answer. Okay, in that case, I think the most likely cause is that I typed something wrong. What we could do we could run it on the sample. I'll just quickly check all these numbers. It's actually plausible that some of the level numbers overflow. So, do we think that's likely to happen? I note that other than by the division by 3, so that'll tell us if it overflowed. Lame. Monkey equals 31,074. Okay. Why are we running monkey 31,074? So M is changing inside this loop. Oh, I'm an idiot. M is wrong. I typed monkey instead of M. Okay, we're back to this. So, yeah, we think the number overflows. So, begins. Such fun. Oh no. These can modify the number in place because we don't need it for anything else. Big mol WX19, big WX8, big mol WX13. Oops. Six. Must check whether this is sound. I'll do that quickly. My suspicion is that's not going to work because it modifies the argument in place while it's multiplying by it. Or does it? No, it creates a new result. So that is fine. Big W X2, big W X3. So maybe we'll just go. No, we want that back. Okay. But there's no more new. There is only old. It's not fast. And if we get to the end of this and it's still the wrong answer, then I think the next step is to also type the sample input into the source and run it with the sample input. Annoyingly, I have no progress indicator. So I have no clue how long this is going to take. Actually, from the lights, I think we're doing about 4 inspections per second. So around is 8 monkeys, and in total we've got maybe 40 things. So around might be about 10 seconds. So in total we'd expect it to take 3 minutes. I think it might have been longer than that already. So maybe it's almost done. Actually, there's going to be a lot more than 40 inspections per round. There's at least 1 inspection per round for each number, and every time a number gets passed up to a higher monkey, it gets inspected an extra time. Should really make the main loop print which round number it's on. Well, hopefully this gives us the right answer and we can move on. If not, make the main loop print the round number, put the sample input in the code and compile it rather than using the interpreter. Without a progress indicator, I don't even know if it would be a win to kill the interpreter and compile it now, or whether I should persist in the interpreter. Also possible that some of my big int stuff is wrong and I've created an infinite loop. Well, if we're pessimistic, we're doing 2.5 inspections a second. We remember from the output we got before that the 2 most active monkeys did about 400 comparisons each. Although that was on random numbers because they'd overflowed, but still. So let's say every monkey does 400 comparisons. We're doing 2.5 a second. That would then take 20 minutes. But it's unlikely to be that bad. So I think you'll finish in the next few minutes. Okay, well, I'm getting restless now. I'm going to go and make another cup of tea. If it hasn't finished when I get back, I don't know what I'm going to do. Excellent. And the numbers are even higher than before. But are they correct? No, they're not. Okay. Firstly, we'll have a progress indicator. Secondly, I want to look in the problem again. So I think that took maybe 10 minutes to run. And if we're going to spend 10 minutes running it, we can spend 1 minute reading the problem. Well, I think I got that right. So we'll have the sample input. told me it's running the sample. It was still passing. Oh, dash sample. Maybe it's a waste of time waiting for this to finish because it's going to take a little while and it's going to give us the wrong answer. So I should have instead made it print out what it's doing. Yeah, as predicted, give us the wrong answer. Okay. Monkey zero can't pass to monkey zero, can he? Did monkey zero pass to monkey zero? Monkey zero passes to 2 and 3. Monkey 1 passes to 2 and 0. Okay, that all looks believable. So there was something slightly different there. If I write down a sequence of numbers that are generated, it's 1501, 1862, 60, 71, 81, 80, 6241, 3600, 9409, 77, 20, 25, 7, 6. Okay, and that's the end of the first round. And then it goes 1976. (1501), 1862, 60, 71, 81, 80, 6241, 3600, 9409, 77. We haven't got the 500. Why haven't we got the 500? Actually, I've got a better idea. What we'll do is we'll just have this run one round. And we'll put it in a file that we can access more easily. It looks like, for some reason, when we pass the numbers around, it's not working properly. Oh, this is going to be so slow. Or is it? Maybe it'll be fine. I'm not using the buffered I/O, so the I/O is going to be quite slow. Maybe spending half, 2/3 on I/O. Okay. I think it was. It turns 97 into 9409. Oh, no, not that. If you try to run killer on a file that doesn't exist, does it crash? No. Don't know what happened there. Yeah, so we try to turn 97 into 9409 into 3136, and then we move straight on to 74. Becomes 77, becomes 25. No, not kilo, more. Oh, okay. Yeah, and then we get 74 becomes 77 becomes 25. And then after that, so after 77, we should have 500 becomes 503 becomes 17. But that's not what we have. Oh, sorry, 50 becomes 167. So did the 500 get passed to number 3? Yes, it did. So he's inspecting an item with level 17 after he's done 74. Whereas he should have an item with level 500. Maybe what we'll do is in pass, we'll say what the number is. Interesting. What is going on there? Passes 17 to monkey 3. Oh, because of the mod operation. because the mod operation changed our divisor in place. So I'll check that that looks like it's doing the right thing. We should see it. We should see monkey number 3 processing a 500 after he processes a 77. Yeah, good. 74, not 77, but good. So we can get rid of some of this printing. We can make it run 20 rounds again. Looks believable, doesn't it? Yes. Right, 6:23:57 we start. Bad. It thinks there are no monkeys. Did I not initialize any monkeys? Stupid. First round took 24 seconds. So we can expect it to take 8 minutes in total. So I'll be back in a bit. Okay, so that took 9 minutes 57. Good. Progress. Now is this going to do the same thing but for hundreds of rounds? No longer divided by 3. Well, saving a division won't save us enough time to do thousands of rounds. However, without the division by 3, without the division by 3, they'll grow very large indeed. Because they never get smaller. However, that does... Oh no, it doesn't. I was going to say it means once you've picked up a factor, you never lose it. However, not all of the operations are multiplication. Well, we could multiply together all of the factors that are used and all of the divisors, which are all prime, and we could do all the arithmetic modulo 3 times 11 times 19 times 5 times 2 times 7 modulo 43,890, which does mean we don't need big ints. It'll be a bit faster. And without big ints and without division, maybe this is in the realm of being able to just brute force it. We might still need big ints. Because how do you work out x squared modulo 43,890 without a big int? Yeah, I think brute forcing it's not going to work. Well, for all of the other multiplications, we can just do repeated addition. In chunks that are small enough that it won't overflow 16 bits. No, that's not going to get... Stop thinking about this, Jess. Figure out the actual answer. Okay, so Monkey 2's divisor is 19. And one of the things that can pass things into Monkey 2 is multiplying by 19. So you know, if Monkey 0 passed a number into Monkey 2, then Monkey 2 is definitely going to pass it into Monkey 3. Well, I don't know. I'm out of ideas. I'm going to stop now. Oh, they've all done part 2. Anyway, I'm stopping. Thanks for watching. Goodbye.